I will do the practical with the SAS. Yesterday, I asked you to convert all these data into SAS form using maybe if you can enter the data in Excel, you can enter it in Excel, then convert it using the remove white space. Or otherwise, you can directly enter the data into the SAS program. Right. Today, we have already seen CRD, RCBD. Today, we can do a Latin square design. I didn't get the example of Latin square design that you have learned. Do you have any information? Latin square design? It is not difficult to do it by SAS. It's easy. Have you done any examples in Latin square? Tanis Kumar. In class or as a homework, did you do any examples?
Yes.
Anybody entered the data in SAS? If so, we can do it. Anyone? Vidushan?
Yes,
Did you enter the data of LSD or Latin square design in SAS format?
no, sir.
No. Okay. Right. If not, then we will go with my example, factorial example. Right. We will start with the factorial example. Later, we will see Latin square design because I didn't give an example. So we will go with the example that you have learned in the class. Then it is easy for you to cross-check the values. Cross-check the values. Right? Okay, right. Now, factorial experiments. Let's go with the factorial experiments. I have already converted the data into SAS form. I will use that data, right? So everyone should convert your data into SAS form, and only you can continue. Right, I have already saved that. So this is my factorial data, the same data that we had. Can you remember multi-program is the factor A, memory capacity of a computer is factor B. Then we have taken the information on what is the time taken to complete a particular program in seconds, right? Can you all remember that? Yes or no?
Yes.
Yes, sir.
Right, right. So I have entered the same data. So that is there, right? To reduce the time constraints, I have already entered the data in Excel and brought it using this remove white space. So you could see here, I didn't write the program yet. I have simply transferred the data. Okay. So now I'm going to write down my program data. Let's say it is a factorial. So I'll say factorial. Give a name, for example, just to identify what sort of analysis is that. So input data, I can say factor A, factor B, replicate, and yield. Factor A, factor B, replicate, yield. And the next one is cards. Have you all written down? This is how we give the initial information. A, B, replicate, yield. Hope everybody has entered your own data. Any questions on data entering? So data, any name could be given, factorial I gave. Input, you can write any name as A, right? So I put it as A, B. It is easy for us to identify. So how many levels are there in A? In our example, how many levels are there in A?
Four levels.
4 levels. How many levels in B?
3 levels.
Right. So everything is indicated here. This is the first level of A, first level of B, and the first replicate. The value is 0.25. Likewise, we have entered the data. So this is the last point of data. Now we go for proc ANOVA. Proc ANOVA as usual. Now you'll have to tell me what are the class. I will ask the name of some of you. You should tell me what is the what are the classes in this example. Kajanita.
Yes, sir.
Yeah. What are the class variable in this example? Classified, coded data or coded information. What are those? Yeah. Kajanita. No reply. What are the classified variables? Kajanita, you will have to answer. Kajanita. I'm going to remove you. Before that, you answer. Kajanita, are you around? Nadasara. NADHA. Yes. Nadasara, tell me what are the classified variables in this example? What are the variables that we have categorized, coded in other terms?
Factor A and B.
Right. Factor A, good. Factor B. What else? One more. Not only factor A, but look at it. They have some fixed value. 1, 2, 3, 4, something like that. Right? These are categorical variable, classified variable. Anyone?
R.
Replicate, sir.
Yes, replicate. Yes, good. Factor A, factor B, and the replicate. So we'll have to write the same name that we have spelled out at the input statement. In the input statement, I have given factor A as A, factor B as B, replicate as rep. So I'll have to repeat the same alphabets. If you change the alphabets, computer doesn't know what you are talking about. Under the input, we have given the name for each variable. So thereafter, we'll have to follow with the same name. We cannot change the name. What is next statement? Anyone?
Model.
Model. Right? What is next statement? Model. Right? Can somebody tell me what is the model? The manual model that for factorial, two-factor factorial. This is two-factor factorial. Tell me what is the model that we have used? I. Now we are learning the practical. Theory we learn. I'm asking the question from the theory. So everybody should know how we can write down the model for a two-factor factorial, because it is two-factor, factor A and factor B. Can you all hear me? It looks like there's a problem.
Yes, sir.
Yeah. Give me a second. Now you can hear now, because sometimes signal goes and come back. Yeah. Tell me what is the model for the two-factor factorial? Because based on the model only, we can write the model in the SAS. Why? Anyone?
IJ.
YIJK.
I, J, K. So we can take I as factor A, J as factor B, and K as replicate. You can take any form, right? So I'm taking the simple form. Now tell me mu plus,
Alpha I.
yeah. What is alpha I? Effect of
Main effect of factor A.
Programming.
main effect of
Factor A.
factor A. Yes, ith level of factor A, main effect of factor A. What is beta? In CRD, yeah? I'm talking about CRD concept. What is beta J? It is the main effect, jth level of main effect of factor B. What is the other important component coming here in factorial?
Interactions.
Interaction. So that is important. First time we are talking about interaction in SAS. Then you have the error component. So this is how we talk about. Normally we don't include these two, automatically computer calculates. So we'll have to include all these things. Clear? Main effect of A, main effect of B, and the interaction. Right, let's talk about the model writing in SAS. So how we can write? Can someone tell me how we can write? What is equal what?
Yield equal.
Okay. I said yield. You can give any name, but I said yield equal
A.
factor A,
Factor B.
factor B,
Factor AB.
AB. So when you write AB, the interaction we write it as A into B, not AB. It doesn't work. Do you understand? Factor A, factor B, and the interaction effect of factor A and B. Now we run the program, right? So run. I hope everyone has written down. Have you?
Yes, sir.
Right. Okay. Then we can execute the program. I'm going to execute the program. So you see the answer is there. We could describe each table. The first table, as you all know, coming usually in the other cases also, the basic information. Let's say what is the different levels of factor A, classes, classified variable A, how many levels? 4 levels are there. What are those levels? 1, 2, 3, 4. That is how we code it. Then B class, 3 levels, we coded as 1, 2, 3. Then we have replicates. How many replicates? 2 replicates. We coded as 1 and 2. So that is the basic information as usual. Here, no problem in the data. All the data are valid data, no missing data. Right, now we go for ANOVA table. ANOVA table, this is most important. Model is significant. Again, I don't want to repeat how we say significant because it is less than the alpha value, it is significant. Model is significant. Now, model is consist of what? It consists of alpha I, consists of beta j, consists of alpha, beta, ij. So you see, this is the main effect of A, main effect of B, and the interaction effect of A. So 3 effects are cumulatively given as model. So that has been expressed in the last table. So you see that is A, B, and the AB. That is how the SAS gives, right? Most of the software gives like that. Now you see, what is the degrees of freedom for A? 3. Degrees of freedom for B is 2. Degrees of freedom for AB is 6. So if you add all these, it is the degrees of freedom for model. Similarly, if you add all the sums of square, that is the sums of square for the model. Right? As I mentioned earlier, that is how the model is split. Right? Clear? Now, in a factorial experiment, what is the first thing that we'll have to look at? First thing we'll have to look at. Anyone?
Effect of A.
Effect of
A. A. Program.
Program.
Yes.
But what is that? Effect of? Yeah. I mean, A mean in our example programming, multi-program, right? Okay.
Yes.
Right. Anyone else? What is in factorial experiment, what is the first thing that we'll have to look at? I mentioned this earlier in the theory class.
Interaction.
Interaction. First, we'll have to look at it whether interaction is significant. So in our case, whether AB is significant. First, look at whether interaction is significant. If the interaction is significant, write down your notes. If the interaction is significant, then we don't look at main effects. We don't look at main effects if the interaction is significant. Suppose if the interaction is not significant,
Yes.
Can you all hear now?
Yes, sir.
Yeah, I will close the video because video giving problem, I think. Okay. I switch off the video because video take another set of, because I am online SAS now. It is the problem. So if interaction is significant, then we don't talk about main effects. If the interaction is not significant, then we go for testing of main effects. Is it clear to everyone? Thanis Kumar?
Yes, sir.
Right. So now, in this case, we have an interaction called AB. First, we'll have to test whether it is significant. What do you say by looking at the probability value? Give me a second. There's an urgent call from our Vice Chancellor. I will attend it and come back to you. Right. I will switch off the video. Can you all see?
Yes, sir.
Right. Okay. We can continue. So, what is the condition here? By looking at the AB interaction, is that significant or not?
So alpha value is more greater than this probability.
Yeah. So
So reject our null hypothesis.
we reject our null hypothesis. So, what is our conclusion?
There is a significant, not significant effect.
Appropriate.
So alpha and the null hypothesis, alpha no I is AB is 0. So
Yeah.
there is no idalar effect irukku. AB interaction effect irukku.
There is an interaction effect. There is an interaction effect. So we reject our null hypothesis. This is our null hypothesis. Am I right?
Yes, sir.
Alternative, at least one of this combination is not equal to 0. One of this combination is not equal to 0. So that means at least one of the treatment combination is different from the rest of the treatment combination. So that means there is a interaction effect. So we could say there is a interaction effect. There is an interaction effect, right? Right. Now what to do? What is next? Anyone?
Find out the main effects.
No, main effects, we said that if there's an interaction, we don't go for main effects, no. I said if there's an interaction, we don't want to check for this main effects because interaction effect is significant.
Mean separation.
Then we need to go for mean separation. Right. Talking about mean separation, yeah.
The mean separation, there are three AB like AB interaction marine and the mean separation AB.
And I'm mean separation. Okay.
Okay.
Right. So what is the next step? We'll have to go for mean separation. Right. When you talk about mean separation, we said let's say if you have treatment, we can do the mean separation directly, right? We don't have any problem. We can do the mean separation directly. Now we have two factors. One is A, the other one is B. The third one, we found that interaction may be there. So in our example, we found the interaction is there. So that we don't want to go back to look at whether main effects are there. So that is the most important. So now interaction is there. Now, once the interaction is there, we will have to do mean separation. How to do the mean separation here? Because here we have factor A and B, right? I will take one example. Nitrogen, we have two nitrogen level, let's say 50%, 75% nitrogen level. This is my factor B. My factor A, right? My factor A, let's say, it is variety. Factor A is actually variety. Let's say by one variety, variety 2. Clear? So I'll have to talk a little on theory, then we will go for practice. Now, when you have interaction between A and B, how we can interpret the results? Variety A, nitrogen A, variety A, nitrogen B. Komada api me interaction leka vistira karanda puluwa. Apita variety kela A factor A, nitrogen kela factor B eka api aran tiyenna. Yes.
Sir, in the inter ipa 50 வீதம் V1 50 வீதம் V2 அதே மாதிரி 75 வீதம் V1 75 வீதம் V2 ல எந்த காம்பினேஷன் வந்து
என்ன V2 50 வீதம் இல்லையே, நைட்ரஜன் தான் 50 வீதம். Right. Okay. Okay. Factor B. Yes. Nitrogen 50%, 75% nitrogen. 2 levels. Yes.
4 காம்பினேஷன்லயும் எந்த காம்பினேஷன் கூட ஈல்ட தருதோ அந்த.
No. Not in interaction. What we say is different. Not the combination.
Okay.
Not the combination. Here, you see. That is what the interaction says. That is the important. If you are looking at which combination is better, no, that is not the results. That is not the results, right? I will take, say, for V1, if you take variety 1, under the nitrogen, let's say 50% nitrogen, another 50% nitrogen, and the 75% nitrogen. The paddy yield, let's say this is paddy, it's giving 4.2 metric ton per hectare. Variety 1. Under the nitrogen level, it's giving 4.8 metric ton per hectare. So this is about the variety 1 as an example. Variety 2, under the same condition of nitrogen, it's giving 4.5 metric ton per hectare. Under the nitrogen 75%, it's given 4.1 metric ton per hectare. Forget about the average yield and so on. Look at the pattern. Look at the pattern. Can one interpret these results? For variety 1, because we never cultivate in the field both variety in the paddy field. Have you seen people are cultivating intercropping of paddy field? Paddy variety. Or field random variety variety. Paddy, I am talking about. May Kaudari Dakaladina we come up yae variety dekak ekawar in dakala dina kawada ekama plot එකේ
No.
no, we don't apply that. Right now, in this first case, if you consider variety 1, which nitrogen combination is better? I simply take this example, right? Which nitrogen level is better among these two?
75%.
75% is better here. High yield from 75%.
So I think in
Wait,
V2, sir, by increasing the percentage, reduce the yield.
No. Wait, this is I took example. Otherwise, I will take another example. Let's talk about variety 2. In variety 2, which gives the high yield? Which nitrogen level gives the high yield?
50%.
You see, this is what we call as interaction. Maybe my example may be nitrogen wrong, but you see, results are different for variety 1 and variety. So when you recommend, do you recommend 75% for both variety? When you recommend, no. For variety 1, 75% recommendation is giving the maximum yield. For variety 2, 50% is giving the maximum yield. So two different recommendations for these two varieties. So this is what we call as interaction. Wait, I will finish it further. Now, again, the same experiment. You may have results a little differently. This is 50%, 75%. Now for variety, I'm getting 4.3 metric ton per hectare. For variety, 1, 75%, 4.7 metric ton per hectare. For variety 2, under the 50%, I get 4.1 metric ton per hectare. For variety 2, 75%, 4.4 metric ton per hectare. Now tell me, which nitrogen combination is good for variety 1? Hello?
Yes, sir, we are here.
Yeah. But no, you are not answering by looking at this. So which combination, which nitrogen is better for variety 1?
75%.
75% is good for variety 1. For variety 2,
Also 75%.
In this case, actually no interaction. I mean, this is what statistically we call it as no interaction. Why? When I recommend, it doesn't matter whether it is variety 1 or variety 2, the maximum yield obtained from 75% nitrogen. But in earlier case, the story is different. For variety 1, good combination is 75% nitrogen. For variety 2, some other recommendation, 2 different recommendations. So this is what we call as interaction is present. Is it clear to everyone? Right, Tanis Kumar. Yeah, no problem. You can ask. Interaction. This is what we call as interaction. Right? I mean, in practically, even though you have so many theory, but in practically I showed what it is interaction. If you recommend the same dosage of nitrogen to all variety, that means there's no interaction between nitrogen and variety. If you give different recommendation to different varieties, then that is called interaction basically. Right? Right? That is called interaction. Any questions? Danesh Kumar, now you can throw your question.
Okay, sir, I understand. Okay, now understand.
So now, I mean, this is called interaction. So in our case also, some difference is there in this programming and memory power. We will see that later in the mean separation. So you understood this question very nicely, right? I gave a example also, no? To calculate, I can remember. Homework. Factorial homework under Tanis Kumar. Not in memory power and so on, variety and we decide or something. Satada Kana. Anyone? So not only Tanis Kumar, others, Saumya, did I give a homework on variety and we decide? Peony, Arosha, on factorial experiment?
No, sir.
Yes or no?
No, sir.
Didn't I give you an homework?
That is for split.
It's RCBD.
Pardon?
Variety and spacing for RCBD into factorial.
Yeah. That is also factorial. Here, factorial mean don't throw that RCBD factorial, CRD factorial. So I gave factorial is one treatment combination setup, treatment arrangement setup. So it can be RCBD, it can be what do you call CRD. All are same. Yes, I gave an example. Yes, it is an RCB. Right. Okay. Any questions? We can do that factorial also. We can go back.
Sir,
Yeah?
excuse me. So one student is asking you, sir, his area power cut down. Vidushan.
Okay. Right. Okay. Right. Now, this is our output. Now we'll have to do the mean separation. So according to my explanation, if there's an interaction, I took variety and nitrogen fertilizer. Different variety, in other terms, different variety responds to different level of nitrogen. Am I right? That is called interaction. Different varieties responds differently to the nitrogen level. Okay. So therefore, we want to do the mean separation, as I pointed out earlier. Right? We did already by showing this. You see here. Here we said if there's an interaction, we said for variety 1, we want to find out which nitrogen is good. For variety 2, which nitrogen is good. For variety 1, which nitrogen is good. For variety 2, which nitrogen is good. So we want to find out those information. Right? We want to find out those information. For variety 1, which nitrogen is good. For variety 2, which nitrogen is good. So we want to do the mean separation, keeping level of one factor as a constant. Write down, keeping the level of one factor as a constant. Then we compare the levels of the other factor, second factor. In this case, we have only 2 factors. If it is 3 factor, it is more complicated. Right? We don't go for 3 factor. We just talk about 2 factor for the time. Right? So do the mean separation for each level of one factor. Right? I mean, keep the levels of one factor as constant, then compare the levels of the second factor. So that is what we are going to do it. Let's do it together. The programming is important. So now, which is easy for us to here, in this case, what is factor A? Multi-program. Factor B is memory. So A1, A2, A3, A4. This is one way. We compare keeping all these and memory. 1, memory 2, memory 3. So we can compare in this way. Under the first level of program, which memory is better? Under the second level of program, which memory is better? Under the third level of programming, which memory is better? Under the fourth level of programming, which memory is better? That is better. For each programming, which memory is better? So we are going to look at that. Can you all hear me? Give me. Okay. Any questions before we go to the program? I'm going back to the program. This is how you write down the program. Can you all hear me? Thanks, Kumar.
Oh, yes, sir.
Right. Any questions?
No, sir.
I'm going to write down some program. You need to write down. Right. We have a setup like this. People may wonder why I'm writing this. Can you all see the program?
Yes, sir.
Yeah. So I gave a proc sort that means we'll have to sort it. But already not necessary sometime because I'm going to do the ANOVA by A. So A is already sorted. Maybe this statement is sometimes not necessary, right? Because A is already sorted. But B is not sorted. If I go along with B, then B has to be sorted. In this case, A is already sorted, so that that command is not necessary. So proc sort by A, right? Then proc ANOVA. We are producing ANOVA separately for each level of A. How many levels are there for A? For A, there are 4 levels: A1, A2, A3, A4. So 4 ANOVA will be produced. I will show you later. So proc ANOVA by A, class classified variable. Now classified variable is B and rep, because already ANOVA A is going for ANOVA, so that we cannot say A is classified variable. So now classified variable is B and replicate. Then the model. We are giving the model for now each level of A. So that model is depend only on B, B factor B, nothing else. No factor A, no interaction. Right, now again we do the yesterday's command, means. We will have to do the mean separation for levels of B, so that I will say B stroke whatever the method that I follow. Whatever the method that I follow. LSD is the method that I am planning. So I type as LSD. Any questions? Any questions? Any questions or any clarifications?
No.
Is it, have you all done this?
Yes, yes, sir.
Right, because I want to run the program. I'm waiting for that. So I'm going to run the program and see the output. Right? You will get a lot of information. You see, this is, you see, what is this? A1, A is equal 1. The information here is given for when A is equal 1. What is A is equal 1? Anyone?
First, the
first level of this program. It gives information for the first level of programming, right? So it's give the basic information, the levels of B and the replicate, total number of observations, 6. So this is the ANOVA, still it is significant, but the most important is we'll have to go and look at it, the lower part, the mean separation, right? So you can see this is the only one component in the model, that is the B component. The most important is this part. Still we are talking about A is equal 1. A is equal 1, right? So I am going to do the LSD. We can see and interpret. Right. So this is up to the level, mean separation. Now tell me the story. Anyone? Now we are considering only A1. Under the A1,
First and second memory sizes are reacting same.
first and
Second memory size,
oh,
element of memory size are
yeah. Memory size are
ரெண்டும் ஒரே கலரா இருக்கிறனாடி சார் அதுக்குள்ள வந்து இது இல்ல
என்ன இல்ல சரி வடிவா சொல்லும்
அது அந்த இன்டராக்ஷன்
இல்ல இங்க இன்டராக்ஷன் இல்ல இங்க நாங்க மீன் செப்பரேஷன் செய்யறோம் இன்டராக்ஷன் ஆஃப்டர் seeing the interaction only here we are doing the mean separation
ரெண்டுக்கும் இடையில சார் பெரிய வேறுபாடு இல்ல
so there is no difference between the first level of B and the second level of B. So that means we can say these are same A and A. The third level of B is different under the circumstance of A1. Right? Now, this is how we can explain. Sorry, I don't want to erase that. We can go back to A2. Now I am going for A2. This is for A2 or A1? This is for A2, right?
A2.
So I can write the same thing here. For A2, 1, 2, 3. So you can write down the values. So this is separately. You'll have to explain this separately. For A1, which is better? For A1, which is better? For A1 programming, which memory is better? Anyone?
A and B are better because both means are high.
Can someone correct his answer? For A1, I'm talking about A1. I will go back to A1. Peony, tell me,
First and
describe.
second one is good.
What do you say? I'm talking about A1. I'm talking about A1, this one.
First and second both are good.
A common.
Because same both
Yeah.
A.
Right. What is this value? Anyone? What is this value? What it represent?
The time requirement.
So if a program comes within shorter time period, is that program is good? Or if the program comes in after submission in a longer time, is good?
Shorter time is good.
So what is good here? A1.
3.
You understand? So you'll have to read the question very carefully and answer it. So here it is the time taken, seconds. After submitting the computer programming, it is the time taken to give the output. So the less time taken would be the best best combination, isn't it? So the third one is good here. In A1, third one is under the A1 programming or under the multiple programming, A1 set of programming. Third memory is good. Third memory mean I couldn't remember, 128 or something, right? MB 128. This is 64. This is 32. All computers. These are old computers, very previous computers. So the large memory capacity is good for first programming. A1 programming. Is it clear? Large memory capacity is good for first programming. Right? Yes.
Yes, sir.
Right. Yeah. இதே மாதிரி விளங்கப்படுத்தின பிறகு கேட்கலீங்களா கேள்வி? ஞாபகம் வச்சிருக்கோம். Look at the A2. Look at the A2. What can you say about A2 then? This is under the A2, programming A2. This is under the programming A2. So under the A2, I will simply give the time taken as such. Right. Now tell me, what can you say about under A2? Programming A2. Second program. Which memory capacity is good?
Third one.
Huh?
0.4.
Why? Why 0.4 is good?
Less
Look
than.
look at this.
0.5.
No. Look at the colors. Is there having a different colors or same color?
1, 2, 3.
Same color.
Same color mean, what does it mean?
All are
Only
equal.
difference.
All are same. Doesn't matter whether it is 32 MB computer or 64 MB computer or 128. All are behaving same. Statistically, by not looking at the values now. Because if I say the grading, I can say this is A, this is A, this is A. In this case, this is A, this is A, this is B. So B is better here. Here all are having same letters. What I said yesterday. Because why same letter, all are having same color. So same color means no difference. Yeah, somebody said all are same. Yes, all are same. So here, even though you have the slight differences in the seconds, you cannot say statistically they are different. Statistically, they are same. Is it clear? So my conclusion is in the A1 programming, third memory is better. In the A2 programming, all are same. I got it? All are same. Right. Tanushan, you can ask now the question.
நான் என்ன கேட்க வந்தேன் சார் என்ன எனக்கு வந்து 25 இதுல 24 தான் யூஸ் பண்ணப்பட்டிருக்கேன்னு வந்துக்கண்டா என்ன காரணம் சார் ஒன்று நான் பிள்ளையா டைப் பண்ண விட்டேன்
ஏதோ நடந்திருக்கு பாரு ஒண்டா விட்டுட்டீங்க
அதான் எனக்கு இந்த மீன்ஸும் வித்தியாசம் வந்திருக்கு ப்ளூ
இல்ல
கலரும்
என்ன மேபி you might have missed out some value. Check it correctly one by one. Yeah, there may be something wrong because that box if says 24 and 25, something wrong because no missing data here. In our case, no missing data, so all data are there. All 25 is there. 4 into 3, that is 12. Not 25, 24. 24 data. Something extra you typed. That may be the reason. 24 data. Total number of data is 24. Why? 4 level of factor A, 3 level of factor B into replicate. So this is 24. Yes, Arosha?
No, sir, given data and type data little different, that's why. Only 3 little different.
What is different?
No, sir, the type data. We typed one and sir, given data different, that's why.
Yeah, why is this different? Maybe my one is wrong. I don't know.
Don't know, sir, we wrote something else.
Huh? Because I'm asking whether I am wrong or you all are wrong.
Don't know, sir. Then I also typed sir once. Sir, given this.
You are getting the same answer.
Yes, now.
Maybe I am not sure whether my data may be wrong or your data may be wrong. So you try, yeah. So that is how you interpret. Right? If you want, I can show you the data. You can cross check. Anyhow, right? Right. We will go because same data which I given you in our class, same data. Maybe I might have typed maybe 1 or 2 data wrong. Anyhow, doesn't matter. Most important is our interpretation. So this is for A2. Let's look at for A3. This is for A3. Tell me what is the story now? Interesting. A3. Anyone?
If we
A3.
compare first and 2, both are same color, so
Yeah.
same as 2 and 3 same color.
Yeah. So how we can interpret this?
So
Anyone? So if you say first and second, they are same. What about second and third? What about second and third?
that is also same color.
That is also same. But what about first and third?
That is different within.
So this is how we can mark it. This is how we can mark it. First one is A, second one is A and B, third one is only B. Now we can represent the whole thing here by this. Can you just identify? Look at this marking. So where we could say there's no difference between first and second. Similarly, there's no difference between third and second. But there's a difference between first and third by looking at the letter. So here, what do you recommend? Which is good one?
Third one is good one.
Yeah, third, not only third one, second and third, we can say, because there are no difference between second and third. No. Second and third are relatively better for program 3.
0.5 time வந்து பார்க்குது.
Langilla.
mean அது 0.625 இது 0.55.
No, because there's no difference, statistically no difference between these two. அப்படி என்ன ஸ்டாட்டிஸ்டிக்கல் தேவையில்லை. இது தசம் 625 இது தசம் 55. ஸோ அது தசம் 6.5 கூட ஆகவே இது கூடான்னு சொல்றதுக்கு ஸ்டாட்டிஸ்டிக்ஸ் தேவை.
Yes sir. Sorry.
So we are using statistics to see whether even there are maybe differences, the values difference, but statistically these are, because we are saying 95% sure, we are 95% sure there is no difference between treatment or the memory 2 and 3 for program A3 statistically. So 95% sure, right? No difference between these two. So these two are performing. Second and the third memory are performing better than the first memory for the program 3. So likewise, this is how we interpret. Right? So the value itself is not enough. That is why we are using statistics. So for example, could you remember in t-test, I want to test null hypothesis, mu is equal 3, our sanity or EC level. But my mean value is 2.89, for example. By looking at this the mean value, and by saying that mean value is much less than the given value, so that without using any statistics, we can say this value is less than the mean value or the population mean value, right? So this is less than the population mean value. So we can write it like that. But here we say in a non-statistical form. Like Jadanis Kumar, இது ரெண்டையும் நாங்கள் வேல்யூவை வச்சு கம்பேர் பண்றோம் என்றால் ஸ்டாட்டிஸ்டிக்ஸ் தேவையில்லை. நாங்கள் ஸ்டாட்டிஸ்டிக்ஸ் பாவிக்கிறோம் எவ்வளவு தூரத்துக்கு இது நாங்கள் ஷுவர் பண்ணி சொல்லலாம் இது ரெண்டுக்கு இடையில வித்தியாசம் இருக்கோ இல்லையோ, எவ்வளவு தூரத்துக்கு ஷுவர் பண்ணி சொல்லலாம்.
ஓகே சார்.
95% ஷுவர் பண்ணி சொல்லலாம், 99% ஷுவர் பண்ணி சொல்லலாம், 90% ஷுவர் பண்ணி சொல்லலாம், எத்தனை வீதம் ஷுவர் பண்ணி சொல்லலாம், இதுக்கு இடையில வித்தியாசம் இருக்கோ இல்லையோன்றது கன்செப்ட். That is why we are using statistics. So in this case also the values are different. You can't have தனுஷ்குமாரோட வெயிட் மாதிரி நீர் என்ன எத்தனை கிலோகிராம் கேட்கறதும் போல என்ன ஹைட் தனுஷ்குமார் உதாரணத்துக்கு
169.
169?
Yes sir.
You mean 169 centimeter?
Centimeter, yes.
உங்களோட கிளாஸ்ல நான் பெட் பண்றேன் இந்த உயரத்துக்கு ஒருத்தரும் இல்லை உங்களோட கிளாஸ்ல.
இல்ல சார், இருக்கேன்.
நான் நுணுக்கமா அளந்தீங்களா? இது நீங்க மில்லிமீட்டர்லயே அளந்தீங்களா? மைக்ரோமீட்டர்ல அளந்தீங்களா? அக்செப்ட் பண்றீங்களா?
இல்ல சார்.
உங்களோட கிளாஸ்ல நீங்கள் ஹைட்டை மெஷர் பண்ணினா இது சென்டிமீட்டர்ல நாங்கள் தசமதானம் கொஞ்சமா எடுக்கணும்னுபடியா we'll have to bring the decimal point in closest value so that we give it in centimeter, right? Because 169 centimeter, right? If I am measuring in millimeter or micrometer, then you could see the differences. Do you understand? It is coming in 3 decimal, 4 decimal, 5 decimal. If you start calculating, measuring, not calculating, measuring, there's a difference. But we take this to the closest value because practically we cannot do it. Micrometer measure with that height. Then you will have to go to Colombo to medical faculty to measure in micrometer everybody's height. Practically we cannot use it. So that is why we don't go for micrometer. Otherwise we could. What I am saying is, if you go on very minute value, actually you don't see the difference. Weight ma padta. Thanushkumar ethana weight. Thanushkumar kekkradhu pilladan. Okay, because batch rep playadukka vandam. Yes.
89 sir.
89 adapa weight correct one, no? Bit high. Right, okay. 89 kilogram. Maybe let's say this is Tanushkumar. Maybe another person, I don't know, another person B is also having 89 kilogram. Actually, these two values are not really equal. Why? If you measure the accurate value of accurate of weight of Tanushkumar, he may say 89.05 kilogram as an example. Maybe the person B may say 89.128 kilogram. If you measure in 3 decimals, 4 decimals, we don't measure in 3-4 decimals, isn't it? Tanushkumar, do you agree?
Yes sir, I agree.
இப்ப விளங்கிச்சா? இப்ப இதைத்தான் நான் இப்ப சொன்னேன். You don't have the same value of the person if you have it in minor units. That is why it is a continuous variable, right? So here what we try to say is, in statistically, even there are difference, we try to say statistically whether this differences exist, statistically whether differences not exist, right? So we want to see that how statistically significant, right? We have talked a little fine. Then the last one for the A4 program. What is the A4 program? Can anyone comment on? This is for the A4. First one is 1.555. Second one is 1.385. Third one is 0.69. Now, can somebody tell me easily can somebody give the ABC for this treatments? Why I am training you all for this is in your thesis writing next semester. This is very important. The way that you write is very, very, very important. Right? Okay. Yes, anyone? How can we write? First, you write the letters, AB letters, then we will explain. Anyone?
First one A, second one A.
Good.
Third one B.
Yeah. Anybody couldn't understand this? That means by looking at this color, right? If I tell in Tamil and Sinhala, first Tamil, இப்போ பார்த்தீங்களாண்டா இதுல முதலாவது பி லெவல், ரெண்டாவது பி லெவல், ரெண்டு பி லெவலுக்கு இடையில வித்தியாசம் இல்லை. அப்ப நாங்கள் அத வித்தியாசம் இல்லையாண்டு சயின்டிபிக்கலா எப்படி குறிக்கிறோம்னா இங்கிலீஷ் லெட்டர் ஏ பி சி அண்ட் அல்பபெட் பாவிக்கலாம். அல்பபெட்டின் மூலமாக இவங்க ரெண்டு பேருக்கும் இடையில வித்தியாசம் இல்லையான்னு காட்டணும். அதே மாதிரி தேர்ட் லெவல் ஆஃப் பி அவர் வித்தியாசப்படுறார் மெட்டாக்கள்ல இருந்து. ஆகவே நாங்கள் அவருக்கு ஒரு வேற அல்பபெட்டை கொடுக்குறோம். இப்ப நேற்றைக்கு நான் காய்ச்சினாங்க மீன்ஸ் வித் சேம் லெட்டர்ஸ் ஆர் நாட் சிக்னிஃபிகன்ட்லி டிஃபரெண்ட். ஞாபகம் இருக்கு, அதை எழுதி வச்சிருக்கோம், மறந்து போகாம எழுதி வைப்பாங்க. அதைத்தான் கைடா பாவிக்கப்படுகிறோம் இந்த நேரம். ரைட்? இஃப் ஐ டெல் இன் சிங்கள මේ B level පළවෙනි B level එකයි දෙවෙනි B level අතර වෙනස බැලුවනම් ඒ වෙනස මේ දෙකේ අතර වෙනසක් නැහැ. ඒක තමයි මේ පාට වලින් පැහැදිලි වෙලා තියෙන්නේ. ඒ නිසා අපි ඉංග්‍රීසි අකුරු වලින් ගත්තනම් ABCD alphabet පාවිච්චි කරලා අපිට ඒක යොමු කරන්න පුළුවන් මේ දෙකේ අතර වෙනසක් නැහැ කියලා. ඒක තමයි අපි මෙතන කරලා තියෙන්නේ A සහ A. ඒ කියලා alphabet දාලා තියෙන්නේ ඒ නිසා ඒ දෙකේ අතර වෙනසක් නැහැ කියලා. නමුත් තුන්වෙනි level එකේ බැලුවා නම් B එකේ ඒක වෙන පාට වලින් තමයි දීලා තියෙන්නේ. ඒකෙන් අරමුණ වෙන්නේ අපි වෙන මේ දෙකේ අතර ඒ කියන්නේ මේ දෙකට වඩා වෙනස්කමක් පෙන්නනවා තුන්වෙනි level එක. ඒක තමයි වෙන පාට වලින් ඇවිල්ලා තියෙන්නේ. ඒ නිසා අපි B කියලා අකුරක් මෙතන අතුල් කරගෙන ඉන්නවා. මෙතන A කියලා දාන්න බෑ. ඇයි? A කියලා මේ දෙකටම අපි දීලා තියෙනවනේ. එතකොට මේක වෙන අකුර වලින් අපිට පැහැදිලි වෙනවා. මම ඊයේ කතා කරා means with same letters are not significantly different කියලා. ඒ අරමුණ මතින් තමයි අපි ABC කියලා මෙතන අපි භාවිතා කරන්නේ. Right? Any questions on factorial? Now we will do a small exercise. The spacing and this, I will go back. Can you remember the spacing and so on? What is that? A spacing example. I will rename it as, everybody can type. I also have the data, so I will type it as. This one is, let's say, variety. I will take it as variety. We are spacing. I will put it as spacing. Then block and the yield. Right? First variety, first spacing, first block. My value is 37. Danish Kumar, is it clear?
Holmes, yes, sir.
Right. The second 35. I also have. Is that the homework that did I give you?
Yes.
Right. I made a mistake. How many blocks are there?
Please.
3. You also can enter the data. Huh? you'll have to be careful how you code it. Hope everybody is. So normally we give the data not in SAS. We give the data usually on Excel or any kind of format of data. Then you'll have to enter the data. So it's easy in entering data in Excel. That is much better. Otherwise, you'll have to be careful.
The 8142
Over there,
8
8. No, code one. Make that.
42
Make that.
yes sir.
Right. Okay. 211. Line 8. Line 8. Line 8. Good. You'll have to say line 8. 21148. Sorry, 28. 212. Two and 3, 30. We'll spend some time for right. This is my data. Now tell me, what is the class? Anyone? What is the class?
Varieties, spacing,
Okay, variety, spacing,
block.
Sorry. Right. What is the model? According to the question that I have given, what is the block here? Sorry, what is the design here? Factorial in RCBD. Factorial in RCBD, tell me what are the components there? Anyone for the yield?
Factor A.
Yeah, now you'll have to tell in terms of variety, spacing,
Variety into spacing,
variety into spacing,
block.
right, block. Good. We can put the block in the front or later, doesn't matter. So this is my model. Everybody agree?
Yes, sir.
Right. So this is additional information in the model, that is the block, right? So the block is additional information because it is in RCB, but it's the same setup. Shall I run the program? Tanis Kumar?
Yes, sir. 1 minute. 1 minute.
Run the program, I will get some water. Right? Shall we?
Yes, sir. Please.
Right. I will execute the program. So basically, we directly go for the interaction, right? You can see all the other information. We go for the interaction. What can you say about the interaction? First, we'll have to look at the interaction, as I said. So here, block effect, because the model expanded like variety effect, spacing effect, variety and spacing effect, and the block effect. Can you remember in the model? Yes. Now, is there any interactions available, existing? Is there any interaction existing? Yes or no?
Yes.
Yes, there's a significant interaction is existing. Why? Because here the p-value is 0.0024. If you take the alpha as 0.05, definitely alpha value is higher than the p-value, so it is significant. Now we'll have to go for mean separation. We can go for mean separation. Write down your own mean separation. Can somebody tell me which one is better? Explaining variety as constant, explaining about spacing. How many spacing there? How many varieties there? 2 spacing and 2 variety, right? So spacing 1, spacing 2. So we can explain like this. Or we can explain spacing 1, spacing 2, variety 1, variety 2. Like this. Which way is better? For a given spacing, which variety is better? That is one way of explanation. Or for a given variety, which spacing is better? What is more logical in explaining? Do you understand? We can do either this way or this way. We can do the mean separation in both ways. But which way is that feasible to explain? That is more important. Variety a constant. Yeah. Can you all hear me?
Sir, இப்பதான் நீங்க காய்ச்சது கேட்டது இதுக்கு முன்ன காய்ச்சது கேட்க.
Maybe some connection. Can you all hear me?
Yes, sir.
Yeah. So what I said is, you see here, there are possibilities in mean separation. one way is we can do it this way, the other way is do this way. So here the first way is, what I am saying is, I am keeping the variety constant and explaining the spacing. For example, for variety 1, which spacing is good? Which spacing gives a high yield? For variety 2, which spacing gives the high yield? So likewise, I can explain the first one. The second one, this is another way of explaining the same results. For given spacing, S1 spacing, which variety is performing well? For a S2 variety, for S2 spacing, which variety is performing well? Which way of explanation is better? First one or second one? Which one is more meaningful in explanation? Both are same. Both are, we can do it in a similar way in SAS. But we should write, for example, if you write a thesis, let either this or that. When you write in a thesis, we can explain in that way or this way. But it should be a meaningful explanation. Appadi explain pannalam. Komada api explain pannalam. Kokada vadiya angata danen explain pannalam.
In the particular variety in the spacing nalla.
That is much more meaningful, isn't it? If you take a particular variety, this spacing is good. If you take variety 2, this spacing is good. That is more meaningful than the if you take the spacing, this variety is good for that spacing. If you take the second spacing, this variety is good for. So that is not good. So this is this way of explaining is good. In SAS, this way is also possible, or this way is also possible. But we'll have to choose the meaningful way of explanation, right? We shouldn't be more mechanical. We should be some practical oriented concept in explaining. Is it clear to everyone? Right, so I'm going to, so for which one we will have to put the ANOVA if I want to explain this? Do I want to put the ANOVA for variety or do I want to put the ANOVA for spacing?
Varieties.
Right, we want to fix the ANOVA for variety. Yes, good. Right, now go back to the program. I will include proc ANOVA, doesn't matter. Yes, because sometimes icons are not working. Look at very carefully how I'm writing the program. So here variety is missed out. Spacing is there. Block is there. So we'll have to keep the block. Right? So block is there. You cannot remove the block. Then you have means. Spacing, stroke, LST. We use the LST. Right? Block effect is already there. So you cannot remove the block effect from the model. So have you all typed? If you have typed, we can execute the program. Anyone? Kajanitha, என்ன ஓடி போயிட்டு டக்குனு வந்திருக்கிறீங்க? என்ன நடந்தது? இருந்தா போல இல்லாம ஓடிட்டீங்க. Kajanitha, suddenly you vanished and came back. Hello, Kajanitha, I am talking to you, not to others. Anushan, can you hear me?
Yes, sir. We finished.
Yeah, okay. Kajanitha is missing, huh? Is she there? She is there, but not responding. I don't know why. Right, we will run the program. So this is the output. We will focus on the mean separation mostly. You see, the model is first you can look at it in the when this is variety 1, for example. This is about the variety 1, right? In variety 1, look at it whether the treatment or the spacing is significant or not, right? The spacing, it's not significant actually. So that means later down, this will reflect on the mean separation of variety 1. So that means no difference between the spacing. So for variety 1, both spacing are same, producing the same yield. I'll come to that, right? Both will have same, you see, without looking at the mean separation, we can say. So I will write down for variety 1, spacing 1, or spacing 2 and spacing 1. Spacing 2 and spacing 1. The yield is 42. In this case, average yield, mean yield 37. So what we say is no difference between these two. Right? Let's look at for variety 2. Variety 2, the story is different. Let's look at variety 2. Variety 2, from the model, you can see it is significant. From the model, it is significant. So we could see there's a difference between these spacing for that particular variety. Let's look at that. Yes, this is the output. So variety 2, spacing 2 is having high 52 as the mean yield. Spacing 1 is having the average yield as 36.7. However, if you look at the difference between these two spacing, these two are two different spacing in terms of producing the yield for variety 2. You see here, for variety 1 and variety 2, how we can give the explanation? Anyone? How can we explain? This is what we call as interaction, at least something different. For example, if I come across here also A instead of B, then no interaction. Here, at least level of one factor different from the level of the other factor, then there's an interaction. So how we can interpret this? Anyone? This is the story. If you take variety 1, there's no difference between these two spacing. So both spacing, another term we can say, rather than saying, there's no significant difference between two spacing. So another term, both spacing producing more or less same yield. There's no significant difference between two spacing in yield. If you take variety 2, which spacing produce more yield? Here we are talking about yield. So which one is better, A or B?
Second space.
Huh?
A.
A is, yeah, second spacing is good. So there's a significant difference. There's a significant difference in yield between two spacing. Then as an next sentence, you can write spacing 2 producing higher yield, higher average yield than spacing 2. Spacing 2 produce higher average yield than spacing 2. So that is how we interpret. So you see, the statements are two different statements. That is why we have interactions. That is why we call there is an interaction. Two statements are different. Right, we will stop with this factorial now. In the afternoon, I will go through split plot and the nested design. Right. So I'll stop with that. Any questions? Yeah. Any questions? Right. If you don't have questions, we can stop with this and see you in the afternoon.
Thank you, sir.
Okay. Okay. Bye.